Awesome. Thank you all for attending this afternoon. Again, my name is Scott Anderson. I'm a bird biologist with the North Carolina Wildlife Resources Commission. And so, as Sarah mentioned, I'm also the coordinator of the state North Carolina Birding Trail. So as the second part of this presentation, I'm going to talk about how to download and manage. Wait, hold on just a second. Let me change my back. Let me go to the next slide here because I have a better title slide. Sarah had the cool birding one. This is kind of how I envision most of this work. So this data is a lot of data. So more representative about what I'm going to talk about today. I want to talk about how to download and manage eBird data, and hope that just this session will be able to relay a few lessons that I've learned pulling these data together. And so hopefully this won't end up being you. To answer Sarah's question at the beginning, I would say I'm about 60-40 computer nerd, bird nerd. So that's where I'm coming from this presentation. So, but essentially what I want to do is sort of the lessons that I've learned today going through this, and I hope it'll sort of start a conversation because I'm sure there's better ways to do some of these things. And I'd love to hear if other people have tried different things or as well. So yeah, awesome. So let's roll right into here. So since this talk is mostly about sort of the details of messing with data and programming and other topics that I sort of personally sort of lean into, but that others might not, I'll be including the occasional bird photo to hopefully keep some folks entertained while I talk through this stuff. So just like you saw all those graphs with satisfyingly upward trends in bird participation, that results in a gigantic file of data that is currently 289 gigabyte text file of eBird data. So if you were to download the entire eBird data set, all the checklists that have ever been submitted, that's how big it would be. And I've done this before, and that if you saw the previous presentation, the slide with the lifetime history of eBirders, this is the file I had to sort of download and sort through. So a lot of this presentation is about how to get that file into a more manageable size and format so that you can do something with it. And a lot of that means just getting it down to the size that it will go into an Excel spreadsheet. That's what I use for a lot of sort of the sorting and graphing and all that kind of cool stuff. So I'm just going to talk through a couple of ways to get that data down into something that's a little bit more manageable. And so kind of the things I'll talk about today, I'm going to first talk about some methods for that. First, identifying what question you really want to answer with the eBird data set, because that will help you, refining that question will help you on the front end make sure you can get a manageable data set on the other end. And I should mention at this point that I'm not going to take up the whole hour today. I'll probably, I've been running 30 or 40 minutes, so there'll be plenty of time for questions afterwards as well. Then I do want to talk about actually the process of getting the eBird data, because there's some nuances to that can make it a little bit easier to process. And making it manageable, like I was talking about, whittling it down into something that you can use in some software or some other methods of using that data. Also wanted to talk about sort of coding and big databases, some other methods that you might be able to employ to, depending on the resources that you have, to sort of host even the larger data sets that are beyond sort of your desktop applications. And I have a couple other little tidbits that I'll mention at the very end, that are related to eBird data. So I'll be including links throughout for other information on how to follow up on some of these techniques. So don't worry about having to frantically type in URLs or whatever while you're going through, because I'll be sure to share a copy of this presentation afterward. Hopefully we can distribute that. So. All right, so what is your question? That's the best first step, because it will help you sort of request a data set that's possibly easier to manage than you might otherwise. And a lot of these questions I just threw up here as examples, a lot of the ones that Sarah had already mentioned. And the other one, like, what effect did a pandemic have on participation in your state or visitation at particular sites? How does visitation at 2 sites compare? That would be a really easy one if you could just pull down their data. What time of day is the most popular for visiting a site? Or what is the most popular site in my state? Or over the course of the year, how does visitation change? We saw great examples of these in Sarah's presentation. But identifying what that question is you want to answer will really help in moving forward with the data. So the first low-hanging fruit, easy way to do this is exactly what Sarah demonstrated earlier, and that's just to go on the eBird website and to their Explore page, and it's ebird.org/explore, and you can sort this by, you can sort of conglomerate the data by major regions, which could be a state or a county or a hotspot even. And you can also have a limited capacity, just sort of limit that to time periods of interest. Your only choices are, you can choose all years, so throughout history, all the eBird data for that location, the current year, the current month, or all of the dates of the big days. So you're kind of limited in how you can whittle that data down. It makes it harder to do some of these analyses with that. If you're looking at just a hotspot and not a larger region, you also have the option to select a particular month as well as the year. So, and obviously, if you wanted to compare hotspots, you'd have to look at one area at a time, and that could be kind of tedious. So if that's not sufficient for what you need, then you'll have to request access from eBird. And so that includes signing into a free account, clicking on the request data link at the bottom of any of their web pages that Sarah pointed out in one of her last slides there. And then you'll have to complete a form with a description of how you'll use that data. And I'll talk a little bit about that later. And so they do have a little bit of a process to gain access to the data. They want to make sure you're using it in accordance with their policies. And I will say at this point that, like, as I mentioned before, it's like, I think this is an incredible policy that eBird has, that they're sharing all this data. It's a wonderful way of just offering this stuff up for other people to use. I think they recognize that there is so much potential for this data that they can't possibly do it all. So they keep themselves focused on certain things. So as I mentioned before, there are two, well, I didn't mention this before, but there are two sort of options here on this page. There's the entire data set. That's like the world data set. That's 289 gigabytes. It's huge. It includes species, and you can download chunks of it. You don't have to download the whole thing. But again, this is structured. This file is structured like Sarah was saying, where you get one row in a table for each species that was seen. So if you saw 13 species on a checklist, you'd have 13 rows for that one checklist. Fortunately, in eBird, they allow you to filter that data a little bit. So you can choose only sightings of a particular species. You can choose a region, and again, those are the same regions we saw before. They could be a county or a state or whatever. And you can choose a date range. So you could choose just a year or just a month or whatever. So it allows you a little bit on the front end here to sort of whittle down your data to answer the question that you've defined. And then hopefully your data file will be a little bit more manageable. The other option is this sampling event data set, which is only checklist data. So there's one row in this, one row for each checklist on this data set. It's slightly bigger when you download it and unzip it. It's 17 gigabytes, or it's slightly small, or it's a bit smaller. Now the problem is it's like all the checklists around the world for all time, and there's no way to filter it. So you'd have to have some way of taking the 17 gigabyte text file and whittling down the records of interest that you need. So it's smaller, but it's still big, checklist only, no species, and you can't filter it. So there's sort of a trade-off there in getting access to the data. I've actually never used that one, although I'm intrigued by it, but I typically just open up the other one and try and manage the best I can with it. All right, some conditions apply. Whenever you download this stuff, they do have a set of files that come with it. It's a big zipped package, and you unzip it, and there's like metadata for all the fields in the record. There's also terms and conditions and the suggested citation. So great ancillary information that they include in that download. But just to run through their sort of conditions for this, for their data, you're not allowed to sort of pass on raw chunks of the data that they've provided you. You can only sort of summarize them and produce products from that data. You can only use it for the purposes that you've put in there for requesting the data. You're not allowed to use it to assist with a bird identification tool. They always want you to acknowledge in any publications, and that's the suggested citation and down below. You can't use it for commercial purposes. Don't make money off of eBird data. And published results should be provided to Cornell. So there's a more detailed version in there, but those are the highlights of their sort of conditions for it, for use of the that whole data set. All right, here's kind of what it looks like. This is a chunk of it. It's huge. Not only are there a lot of lines in it, but there's also 46 columns in the data set. And like I mentioned, there's a detailed document that comes along with it that tells you what each column means in there. So each field is separated by tabs. So opening a text editor kind of looks like this. Couple wonky things. It's sorted by species. This is sort of an example. It's actually not the actual data set that you would get. So I looked at one for 2020 for North Carolina, and it was like one record for American black duck and then like American crow for like hundreds of records. So that's a little inconvenient if you're kind of trying to go through record by record. All the checklists, all the records for one checklist are not clumped together. It's by species. And again, just to point out another piece of that where Sarah said that one row is a species. There's a lot of columns in here that are common among checklists. So there's a lot of repeated data in this table. There's the date of observation is the same, the location, the country, all those things are all the same for a bunch of rows in that checklist, regardless of, for every species that were recorded. All right, so I wanted to run through a couple. I'm not going to go through all 46, but I wanted to run through a couple fields that are pertinent that Sarah also mentioned some of them. So the first two is this global unique identifier and the sampling event identifier. These are like just IDs for the global unique identifier is an ID for the species checklist combination. So that's different for every row in the table. Sampling event identifier is just different for the checklists. Observation date, like Sarah mentioned. Observer ID, I will mention that this is sort of a goofy obfuscated identification. You can't really ever tie it back to a particular eBird user, like a eBird username or anything. It's just a OBSR and a bunch of numbers. So unless you really worked hard at it, you wouldn't be able to identify this. So there's not any sort of personal identification. There's the location bit. Again, we talked about this before about coordinates. There's coordinates there that could be either a hotspot or it could be a personal hotspot. So there's a little bit of wonkiness there with the spatial accuracy. There are these fields: locality, locality ID, and locality type. Again, these are like the name of the hotspot. the name of or an ID value for that hotspot, and then there's a letter value for the type that's somewhat useful. And then of course there's also country, county, and state, so you could filter by those pretty easily. Time the observation started, duration in minutes, again we talked about these before, distance in kilometers, again that's like, you know, if you're using the track log, you start a checklist and you start walking and you walk a mile, or they put it into kilometers, you know, you stop it, then it will record that distance in here. Number of observers, as I mentioned with the wings over water example, you can say if you're in a group of 5 people, you can say there were 5 people. You can share that checklist. Is it a complete checklist? That means, you know, people can select this value if they are, you know, if they've identified all the species that they can, or if they recorded all the species that they can identify. That's what I meant to say. There's a group identifier, so if you do share this checklist with other people and they accept it as, yep, I was with this person, we were birding together, you can sort of tie those records together if you want to with that group identifier. There's that protocol type that she mentioned earlier, which is traveling, stationary, incidental. There's a bunch of others too, but those are the most common ones. Incidental just sort of means it's usually a checklist. It's not a complete checklist. It's like I was driving along, I saw a red-tailed hawk and I wanted to put it in, so or hopefully we're just riding along and we're driving. There's a project code in there, which is like a portal name. Some states have their own portal in eBird. It's like their own little corner of eBird. Atlases often use eBird to collect data, and so they have their own portal, and it'll stick that project code in there. You can actually select this portal when you're in eBird. You can go to the settings and choose to contribute to a particular portal. All it really does is just add that portal name into this field in the eBird dataset. And then there are the species specific ones. So there's the species name, the group, and also you can also put in the type of species identifier it is. So it could be a crow species. We have fish and American crow here, so sometimes people will put, you know, crow species, not identifying the particular species. So that's in there as well. And there's breeding codes, so you can record behaviors like I saw a bird carrying food or nesting material, or I found a nest, and you can actually record those in eBird as well. And so that's in there. What's not included in the eBird dataset, like I mentioned before, there's no usernames. There's no tie back to a eBird user, and there's no track log. So, you know, like we were talking about before, you start it and you walk along. It's actually, eBird's actually recording that track if you allow it to, but you can't download that with the eBird dataset. At least not yet. I don't know if there are plans to do it. Okay, I wanted to give you a little bit of context for how big of a file might be for different geographic regions. And to do this, I sort of calculated it. It's about 5 kilobytes of data for one checklist, and that equates to like almost 14 rows per checklist. So on average, this is just North Carolina data, but I just extrapolated it to the rest of the country. But people record 14 species per checklist. So those are some things that I used to calculate some of how big some of these data could be and whether you might be able to handle it with whatever software you're using. So in North Carolina, for instance, this is 2020 data only. We had 199,000 checklists, which takes up about 1 gigabyte of space, and that's 2.7 million rows. If we compare that to other states, here's the North Carolina data. Also looked at some of the trends here. It's fascinating to me to see how some of these trends are different from state to state. You know, we're up 44% in checklists, 23% in eBirders from 2019 to 2020. If we look at Maine, you can see comparatively, you know, they only had 136,000 checklists. They're only up 21% in their checklists, and they're actually down 7% eBird participation for them. So it's an interesting, I don't know what's going on there, but sort of an interesting question of why is it different in Maine versus North Carolina. We can compare that to also New York. You can see New York has a lot more checklists, a lot more eBirders in their state. They were up 45% in checklists, but only 20% in eBirders, so pretty similar to North Carolina. But clearly they have a lot more people using eBird. Cornell's in New York, so that might be a pretty big factor. And then I decided to compare it to entirety of Canada, just to see what that looked like. And so that would be 1.5 million checklists. And you can see the file size there is about 7.6 gigabytes. So you're looking like, depending on the state and how much participation you have, you could have anywhere from a little under a gigabyte to 8 gigabytes for an entire year's worth of data. And that's only what's 2020 data. Who knows, looking into the future, that's only going to get bigger. All right, so if those are sort of the sizes we're talking about, like let's see what that means in terms of what you can manage with some common software. So for Microsoft Excel, that means you got a limit of 250 megabytes and 1.1 million rows. So, and then Access has a 2 gigabyte limit, and then there's other options which I'll talk about, which are essentially unlimited in how you can use them. But so if we look at some of these states and where they would come out on this line here, that North Carolina and Maine you might be able to manage with an Access database. New York, you're kind of above that, you wouldn't be able to do it, and Canada's way out there. So just sort of a comparison of what you could do with some data. The nice thing about Access would be if you could get your data into Access, you could probably spit out a nice chunk of it to do some more work with it. So some of those other options. I'm going to talk about a Python script that I've used mostly to manage this data, but before I do that, I do want to talk about GitHub. If you're not familiar with it, GitHub is a website that's essentially a space to share any kind of programming code. If you've written a code for it could be a website, it could be an app, it could be just a script like this. It's a big community of people who sort of shared code from across the world. And it's a great resource for not reinventing the wheel. If you're wanting to look for eBird data, I'm sure there's other scripts out there that people have written to sort of manage eBird data. You can go on GitHub and just search for eBird on there and see what other people have written. At least it gives you a starting point if you have somebody or you're programming in Python. So highly recommend that. And this Python script I'm going to talk about in a second is up on GitHub. So you're welcome to download it and make your copy, make modifications to it, show me all the cool features you've added to it and share it back with me. GitHub's a pretty powerful tool for that kind of stuff. So that's cool whether you're working with Python or R code. There's a lot of R code. There's a lot of Python out there too. So it's a great way to share sort of these resources. So my Python script is sort of a little script that does a couple things. You still need to download that eBird data set, and you can, whatever slice of it you want to download. But once you've downloaded that data set, you can change a few, you can do some filtering of it by month, year, state, county, or species, or any combination of these. Like you could pick whatever combination of years, either a range or just selected years or a bunch of states. It's pretty flexible in what you can do in there. So you just have to point it to where your file is that you've downloaded and enter in the code for these species. And there's some comments in the code that you can see there as well. So you can filter out that sort of database that you've already downloaded, or that file that you've already downloaded that's on your hard drive. And then it spits out mostly three files. One is just a table of checklists for 1 year of data in North Carolina. That's usually small enough for me to throw it in an Excel file. So that's the gold. It's my gold standard. If I can get it that small, then I'm happy. But it also has a unique species count for whatever filters you've put in there is another file in there. And then there's a bigger file, which is usually too big for Excel, which is just a row for each species checklist combination. without a whole bunch of redundant data. So that's what that spits out. So that's this Python script, or some version of it, is what I've been using to come up with a lot of those tables and other things that we've been showing you. So again, that's up on GitHub. I also wanted to share with you another possibility, which is if you have somebody who's skilled with R, there is a package in R called awk. And using that package, you still have to download the eBird data file, put it on your hard drive somewhere, point R to it, and use this package to sort of sort. And I imagine it's worked similar to how Sarah used SAS to sort and manage the data. So I'll mention that there's a GitHub link down there to one of my coworkers, or that our partners for the North Carolina Bird Atlas, and he was working with Atlas data, but it's still an eBird, so it's still relevant here. But he was able to use these R code, which is posted on GitHub, to create basically a summary page. You can run this whenever on whatever date range he wants, and he's just sort of coded out different ways of chunking the data out, and it spits out a nicely formatted HTML file like this, and just sort of summarizes all of our eBird or our Atlas data. And you can put graphs in there. He's got a map in there too. So another possibility for managing this sort of huge data file. And again, that's on GitHub. So we talked a little bit about this during the question and answer session before. But I did want to mention how the sort of challenges of taking these eBird checklists and then associating them with either a conservation area or a birding trail site. As Shelley mentioned, birding trail sites can be not under one jurisdiction, and so you've got all these different data sources, and you may have a shape file for some of them and not for others, and there might be multiple hotspots for a particular site, or there might be, for one of our sites, we have multiple birding trail sites on one game land. So it's really complicated in trying to figure out how to tie these two sets of data, or the eBird data, to your whatever sites you're trying to associate them with. And one approach is to do what Sarah did, and that's use the hotspot moniker, which I think is a really great low-hanging fruit way of doing it. I used a little bit sloppier method where I buffered the birding trail sites by about 3 miles, and then sort of just did a spatial query of where those eBird sites were and where they overlaid with those buffered dots, just to get an idea of visitation at those birding trail sites. Again, there's some problems with that, but it's let's see. So yeah, these are our eBird, or our birding trail sites across the state. And again, you can sort of do some comparisons like this, like what percentage of checklists were on birding trail sites in 2019. This is 2019 data, and what 71% of our people who had submitted eBird checklists that year visited a birding trail site. So again, I had to whittle the eBird file down to something I could fit into Excel or load it into ArcGIS to do this sort of spatial query work. And so, but this is sort of the next steps and some things with that. So this is just a plug for one of my favorite features in Microsoft Excel, and it's once you have that manageable file, I find Excel to be so powerful for parsing and manipulating, or just finding some of the interesting trends or comparisons in the data. I'm sure most of you are at least familiar with Excel, but I did want to mention one feature that has proved really valuable to me poking through these data, and that's using a pivot table and a pivot chart. Like this is a pivot chart right here, and then using the slicer. The slicer is this thing on the right here, where it's got this is data from a joined list of sites and birding trail sites and checklists. And so you can just click those buttons on the right and choose what sites you want to include or not include in this table or this chart of monthly observers visiting those sites. So you can mix and match whatever, like the example that Sarah gave. If you had a list of all the wetland sites with other sites, you could do that comparison pretty quickly here. It's really awesome. So I highly recommend sort of poking around with that and trying it out. All right, reaching the end here, so hang on. So yeah, big databases. So yeah, another approach, rather than trying to whittle this file down to a manageable thing through either querying a smaller set or using the Python script or the R script, is to just chunk it all into a huge database that can handle it. And you like Sarah mentioned, I'm not a professional with any of these, but so I'm just putting these under the lump of professional support for the SQL Server or MySQL or Postgres SQL. If you can get it in one of these large databases, it's much easier just to query the whole thing with the chunks that you need, rather than having to try to kludge together these things. Having said that, I will mention one software that we've used for the bird atlas in North Carolina here that's become really useful, and that is this awesomely named software called MongoDB. It handles really big data really easily. It's really useful. So it's an online database service. It has really strong support for sort of database newbies. You can kind of click through like uploading data to it. You can create these really cool dashboards. Like this is a heat map of North Carolina. I just sort of dumped a file that I downloaded. I think I dumped the 2020 data for North Carolina straight, from eBird into this data set, and it took me, less than 20 minutes to sort of, once I had the file, to upload it to there. You can create a whole bunch of other dashboard options. There's charts and dynamic charts that you could, as you update the data, you can look at the summary of those charts. I just put on the bottom there is by week, the checklist by week for North Carolina, and it has like the protocol type or the different colors. I find it interesting there is on week 7, I think that's the Great Backyard Bird Count, where a bunch of stationary counts like outmatches the traveling ones, which is the norm. So cool stuff like that you can sort of look through with this. So yeah, the link down there at the bottom, this MongoDB Cloud Atlas, it's really been powerful for our Atlas data, and I think that's what we're going to use for managing that data. All right, and then I'm on to my little tidbits here. So one of the tidbits is this sort of eBird API. If you're not familiar with an API, it stands for Application Programming Interface, and it allows real-time access of eBird records. And there's, but the problem is you can't like download big chunks of data. You can only get really small chunks of data, so you're kind of restricted with that. And I'll show you an example of how you might use this in a second. But some of the data that it does provide, you can, give it a location or a region or things like that, and you can return all these recent observations for that region or area, like the last 30 days. What's notable, the notable birds that we're seeing in that area, a single species, what was that seen, when has that been seen in an area. You can pull down information, all that information is available on the website, like the top 100 contributors for a given date, all that summary data that you saw on the page that Sarah was showing about the hotspot or the state level sort of summary data, you can pull that down. And then there's a whole bunch of reference information out there too. Like if you're submitting you're using this API to say, hey, I'm in this region, what are the adjacent regions? You can get a hotspots for that region, all the hotspots in a particular county, for instance. The eBird taxonomy, there's a whole list of their what their naming conventions are for all the birds. Region info, sub-region list, all that kind of stuff. So this is really useful for very small, like real-time data. And we use this on the North Carolina Birding Trail website. If you go on that website and you look on our map and you click on one of our sites, like this Hemlock Bluffs Nature Preserve, there's a little birds tab there. And when you click on the birds tab, it sends a request to eBird while you're, as you're looking at it on the page. And then eBird sends back this list of notable sightings nearby. And so you can just throw that in there. And so it's real-time information, like Sarah's mentioning how real-time eBird is, that you can sort of throw on there. It's not really for this big analyses of trends, but it's great for sort of these sort of website, interactive website kind of applications. And that's pretty much all I've got for you today. Thank you again for sticking by and listening, and hope some of this information was useful to you. And I hope that if somebody has some better solutions or better ways of doing some of these things, that they'll share with us, because it can be really tedious, and I'm often that person on the first slide or the second slide that I showed that banging my head against the desk trying to get this to work. So thank you all.
Thanks, Scott.
Thanks so much. Yeah, if y'all have questions, he left time for questions because it is a lot to chew on. But if y'all have anything to ask, please put it in the chat. My chat is getting weird, so if anyone sees chat, feel free to get it. My computer kicked me off again. I swear I've been kicked off more times in the Zoom than I've kicked off ever in my life.
I don't see any questions in the chat, Shelley. I know it's a lot for people to digest.
It is, and I am glad we're recording it, because there were several slides I was like, oh, I want to take notes. I was like, no, I don't have to. They're right there.
Yeah, and the technical questions, I've given quite a few of the first hour, and with Scott at the last Academy about the background, and then people always have follow-up questions. Well, how do I do it? I want to do it. And so Scott's portion is just so helpful in getting into the tedium, because be prepared. If you go down this road, it is very tedious. There's a lot of things, but if you want simple statistics, it's not too terrible. But Laura, yeah, I have fast flashbacks.
Yeah, think about who in your agency can help you. Like, it doesn't need to be you remembering how to use SAS from grad school days or learning MySQL or something like that. Like, maybe it's figuring out who the data analysts are at your agency, and if any of them have bandwidth to take on a new project with you, and then maybe reviewing this presentation with them. Or maybe it's also getting your GIS analyst involved if you need someone to help you with the shape files or the data points of all the sites that you're interested in. So I think really expanding who your partners could be in your own agency or with partner organizations, so that, because it can be overwhelming. Like, if I think about this for me, I would have to do a lot of homework to get anywhere near able to dig in. But when I think about the talent we have at our agency, it becomes more manageable. It becomes a digestible thing, I think.
Another path we've walked down is it's been easier with the Atlas project that we've been working on, but we're actually got a structure in place with that MongoDB database that we're set up so that when the end of the season comes, we can send an email to every person who contributed to the Atlas, show them here's all the hours that you contributed to the Atlas. Are you okay with us using this as in-kind contributions for our federal grant? And they can check it, sign off on it, and it's the feds have sort of agreed to that process. So if that's a carrot that you could use to, like, hey, we want to get some of this data, like if you can get data people to help you with that and say, and in addition, we can get this in-kind data. I don't know if anybody's done it when it's not an Atlas, just like, hey, if we're using this eBird data for conservation, like, it could count towards in-kind. Just if you could coordinate with your Fish and Wildlife Service rep for some of those federal grants, it could be really a game changer, especially looking forward to Recovering America's Wildlife Act, if we can use that as a way to leverage some of that funding as well.
So we have a question from Megan Evans. It says, hi, everyone. A great summary introduction. Wondering if either of you could say a few words regarding the use of Cornell's species science products, such as weekly relative abundance models.
I don't know much about those.
No, I don't either. If you're talking about the abundance models, like the animations and yeah, the abundance maps and things like that, I'm not sure exactly what you want to know, but I think that they're really valuable. You know, any large scale, it's tough because this is clearly community science or citizen science, however you want to say it. It's not perfect, but the breeding bird survey isn't perfect either. No survey or monitoring type census event like this is perfect at a scale this large. And so I always try to think of that. I mean, I view eBird as kind of the best way that we have to especially look at species abundance now at a scale this large, especially across the full life cycle on overwintering grounds and stopover sites. That's incredibly valuable to a lot of the things we do working with southern wings and habitat stuff, which I mentioned at the beginning. But I don't use them as gospel, but they're way more data heavy and data driven than a lot of any of the other ways we have to look at many of these species. And so you just look at the abundance map, which I won't go into the screen sharing again, but if you just go to eBird and go to the science tab at the top, it's the first thing comes up at the front. Abundance and what's it called? The oh my
Explore.
God. Yeah, it's on the science tab, and then when it opens up, you'll see the abundance. You just click on that, and then you can search by species. But there's like 600 or 700 species in there that you can search by, and it shows you an abundance map, not just a range map. You know, you compare it to a range map, and a range map. What does that tell you? It tells you anywhere that the bird could occur in winter migration or breeding. You compare that. I have another slide on another presentation about this. They're side by side, and one's just a range map and one's the abundance map, and it's just night and day because abundance is clearly telling you the most important spots for a lot of these species. And because eBird, the data is it's so data heavy, it's, as I said, it's contributing to science and conservation in a lot of ways by informing things like Partners in Flight's Avian Conservation Assessment Database, which is the way you can look up any North American species and look at its, concern score, its concern score for overwintering threats, breeding threats. It's just this compilation of 5 or 6 scores. It really gets into the tedium, for real, of threats to birds, declining birds, and that informs regional conservation lists of species. And so all of that, eBird is now informing a lot of that stuff where we can look at those abundance maps to build SGCN species lists across a region. And we just did this with MAFWA, CIAFWA's done it, and the AFWA. And we're all looking at eBird abundance maps just for context, not to say this is gospel, but just to give us some context of what areas or parts of the world they're relying on in different parts of the year. And it's a lot more rigorous in some ways than a lot of the other efforts we have, but it's not as standardized as BBS either. So each has their issues and high points.
Yeah, I'll mention a couple things on that I was thinking while you were talking. As since we're doing this atlas, you look, like Sarah put up that map of all her checklists for 1 year, and I kind of briefly put that up for mine, and you could see like that map of eBird checklist represents like some unquantified amalgam of where people are and where birds are. It's like you don't know what it represents really because there's two things going on there, and I think eBird has done a pretty good job of, I don't know if this is kind of getting to your question, but like figuring out how to deal with that in some ways. But the result is that their abundance blocks are like 20 kilometers on an edge or something. They're really big. So if you need more fine scale data, like you want to tie a detection to a habitat type, like you're going to need a more structured something, like BBS data, or like we're trying to do at the Atlas as well. So that's kind of one of the exciting things I'm looking forward to with the Atlas. We've actually are working through trying to get a graduate student or a PhD, a postdoc, to work on some comparing these eBird data with some of our our sort of more structured, skilled, super skilled, well, I shouldn't say skilled because a lot of eBirders are super skilled, but the sort of more structured surveys that we're doing. And it's like, is it worth it to do these structured surveys? So we're hoping to get some of those answers with the three things that are going on: just regular eBird, our Atlas, and some of the structured surveys. I don't know, kind of wandered around that question, but.
Well, and another thing I want to point out is that, like, I'm clearly not a statistician here, but eBird is able to look at abundance rather than just presence, absence, or just raw data, because they're calculating the time spent and the distance traveled. So they're able to incorporate that into a model that quantification of effort over these broad scales and time all come together in a model to look at the abundance of where birds are more abundant than other areas, to show that on a map. They're not just showing concentrations of detections. They're incorporating a lot more than that on the back end to create those maps.
Yeah, that's a good point.
Good question.
Any other questions from anyone?
And if you all have follow-up questions, our emails were up there, and we can maybe include that on an email. And I'll just put my email in the chat, but it's just Sarah.
I do the same thing.
Yeah. So follow up if you have questions. I'm always happy to talk.
All right. If there aren't any more questions, then I will call it a wrap. We can stop recording. And thank you all for coming.